So let's discuss weekly contest for 96. We'll be going through our solutions of this weekly contest problem. So without any further ado, let's jump into the video. So the first question is mirror frequency distance, and the question reads as you will be given a string S that has lowercase character, English letters in digit, right? And for each character, we are defined like mirror character. What for a character? What is the mirror character? So okay, so if the if the ch like if the current character is a digit, in that case, if it is a digit, in that case, if it's 0, then it will be 9. If it's 1, then it will be 8, and so on, right? And if it is a letter, right? If it is a letter, then if the character is A, then the mirror character will be Z. If the character is B, then the mirror character will be Y, and so on, right? Now we are also given this particular thing to look into. So let us assume like the current character is C, right? Then the mirror character will be M, and frequency uh, of X denotes the number of time. So we need to find the absolute difference of the frequency, that is frequency of the character minus frequency of mirror character, and the absolute difference, right? And we need to store it into our answer. And the mirror pairs C comma M and M comma C are same, and them should be counted only once. That is, we should not count twice. Like if it's 0 comma 9, then we should not count 9 comma 0 again in our answer. Okay, and we need to return the integer denoting the sum of these values over all the distinct mirror pairs, right? Let's understand with this example. It will be a very uh, easy or dry run to understand these problems. Okay, so let's SB this, right? So what do we see, right? So let's understand if this is the current character A, right? Then its meter character will be Z, right? And frequency of A in this string is 1. Frequency of Z in this string is also 1. So net frequency C minus M, C minus M is 0. So we'll add 0 to our answer, right? Again, now let's come back to B, right? For B, the meter character will be Y. Frequency of B is 1 in this string. Frequency of Y in this string is 0. So absolute difference of these two frequency is 1, right? Now if we see like 1 for 1, the meter character will be 8. Frequency of C, that is 1 in this string, and frequency of 8 in this string is 0. So absolute difference is 1 of this two, right? And again we come back to this 9, then meter character will be 0, and this frequency of C is 9 is 1, and frequency of 0 in this string is 0, so difference is 1. We have not calculated for Z, for character C is equals to Z, because the meter A comma Z was already included. Hence if we have calculated this Z comma A, it will have violated this condition, like this would have been counted only once. So that's pretty much for this one. So let's understand the constraint is 1e5 5e5, and S consists of only lower case letter and digit. So let's understand it, how what will be our intuition for this particular problem, right? Okay, so let us see if S is given to us like A, B, or something Z 1 9 or something, right? Then what will be the first thing? The first thing that I will do is I will store what is the frequency of characters, right? The frequency of characters from A to Z, because if okay, and also the second thing is frequency of digits. This will be letters, right? Frequency of digits from 0 to 9. Now once I have this, right, so what I'm going to do is I'll run two loops. One to count what is the contribution of characters, and one to count what is the contribution of digits. One is like letter, not characters. Okay. So what I'm going to do is like I'll run a loop. So uh, I'll run for character, that will be from A, and character will be less than equals to Z, and character plus plus, right? My C will be equals to CH, right? And what will be M will be equals to, so mirror is Z minus C, right? And then now one thing is like we know like if we have included a comma z, then we should not include z comma a, right? Because that will be violating the conditions given, that will be counting twice. So we can keep a dry thumb rule is like our first character c will always be smaller than m. Okay, so this should always be smaller than m, and in this way we'll be able to exclude these conditions where this won't even occur once. So if c is less than m, right, in that case what I'm going to do is I will add it to my answer, absolute of this frequency of c and frequency of m, right? This will be one case, and I'll also run a loop for digit that will be from 0, and digit will be less than equals to 9, and digit plus plus, that will be same, c equals to digit, right? Then m will be equals to 9 minus c, and if c is less than m, then I will store the same thing, like right, this one, answer plus the absolute of frequency of c minus frequency of m, and at the end I will return this answer, right? So that's pretty much it for this particular problem. So let's even understand this. So I have a map, like first one is for the letters, and this is for the uh, digits, right? So I am storing it, the frequencies of both of the, like let digits as well as the digits in this as well as the letters, and then I will run a loop for the first like uh, let letters like 0 to 26. So my c will be equals to I, and m will be 25 minus I. So I've just done this, not, but you can even do like z minus c, that will work as well, right? And then if c is less than m, in that case I will calculate the absolute frequency, I will add it. Similarly for this zero digit 0 to 9, I've done this, and I think that should pass the submission. Yeah, that was pretty much it for this problem. So let's move on to the next one. Okay, so this was given integers with multiple sum of cubes. Okay, and we are given an integer n, and integer x is considered good if there exists at least two distinct pairs a comma b such that a and b are positive integers, a is less than equals to b, and x equals to a cube plus b cube. Okay, and we need to return an array containing all integer less than or equals to n sorted in ascending order. Okay, so let's understand with this example, right? So for n, if you see, right, 1014, right, uh, 1014, and we need to count all the integers such a comma b such that their cubes sum, right, is less than equals to n. So if you take like a equals to 1 and b equals to 12, in that case it will be 1729, which is less than equals to 1004, uh 4104, right? So this is one, so the sum is 1729, and again it can also be obtained via this, like if a is 9 and b is 10. Similarly for 4104, if a is 2 and b is 16, their cube summation is 4104. Other ways, like if you take a is 9 and b is this, then also we'll get this. Okay, so the two possible answers, x will be like this and this, and right, and there is also given two cases, right? If there are at least two pairs, right? So we see like for this there are at least two pairs, this and this. So that is why we're counting it. If there was like, let's say if for this one only one pair was possible and this case was not possible, right, then we would have not counted this. So at least it needs to be two pair, right? Let's, in this question, the very important thing that was the constraint, right? N is less than uh, 1 to the power 1 right? So let's see how I approach this problem basically, right? So I saw like n is uh, 1 at worst case, right? And we know like for 1 if I say numbers x, let's not say it's x, I such that I cube is less than equals to n. In that case, how much is it possible, right? So if we put like I can be, I at max can be 1000, 100, okay, 1000, because 1000 into 1000 into 1000 is 189, right? So our I can be like, uh, our I can be from 1 to 189 in worst, one it's 1000 in worst case, right? I'll say. So what I'm saying is like, uh, which all numbers are there such that their cubes are less than 1000, right? So I will first of all get all the numbers such that their cubes are less than n, individual cubes, like get list. So it will say get all numbers such that if I is the number, I cube is less than equals to n, right? So once I have the list, so let's say I have the list like, let's say 1 2 3 4, right? So it says like 4 cube 64, right? So so let's say our number was 65, right? N is 65. What? Okay, so this is our list. So I know what all values are there whose this is possible, right? So once I have this list, I know what I can do is I can run loops and I can say, uh, I'll say okay, what all numbers have appeared, right? So I'll take one and then I will say okay, so this is the list, and I can also store it like this in a better form such that I don't have to calculate it. 2 cube is 8, 3 cube is 27, and 4 cube is 64. Okay, so this is the cubes of this particular. So list is this, right? This one will say. So I'll say okay, if I take one, what all possibles are there? 8, 27, and 64, right? So what is the sums that I getting? 1 and 8 is 9, 27 and 1 28, and 1 and 64 is 65, right? Similarly, if I take 1, 8, what all possibles are there, right? What all, oh, I can also take 1 as well, right? So 1 and 1 2, because it says like A and B, A is less than equals to B, if you see here. So A and B can be same number as well. Now if I take 8, right? So what I can do is 8, 27, and 64, right? So 8 and 8 16, 27 8 35, and here if you see 68 and 4, it's 72. Like this won't be possible because it's exceeding. If I similarly continue with 27, so what I can do is 27 and then 64. So 27 and 27 is 54, and this will be of course greater than 65, right? Similarly, if you get 64, it can only be paired with 64, and 64 and 64 it will be 128, which is greater than this. So if I say right, there aren't any number that has appeared more than once. So this was not a good example, but I hope you understood what I was meaning to say, right? So once I have this list, I can try to brute force for all this particular and see how many times any number which is less than 65 has appeared, because we'll cancel this. So if you find any number, right, which has appeared more than twice, which has appeared at least twice, right? So I can have I can include it, right? So if I say what is the frequency of 2, how many times 2 has appeared? It has appeared only once. How many times 9 has appeared? 9 has appeared. This I can store like only once, right? So this is the way actually we're gonna do. So this was basically the intuition that I was trying to do. So I will get all the numbers whom I can do, and then I will try n square. I will take all the possible one with every other numbers, two with every other numbers, and then I'll see okay what all values I'm getting, what all numbers I'm getting, who's and the possible sum that I'm getting, and which is less than n, uh, and if there are any which have frequency less than 2, greater than equals to 2, I will add it in our answer. Okay, so this was the list. So basically this function is the get list, which finds if I'm giving a number n, all the i's such that this was even not needed, it should have been n, right? All the number n such that uh, the value is less than equals to n, right? Okay, such that the value is less than equals to n, and then I would return this. So this particular part is returning us this thing, this. So once I have this, I'll store a map to calculate the frequency. Like this will how many times 2 has appeared in our all the possible iterations. Like when we did brute force, like one with every other number, one with one with 8, 27, and one with 64. So let me delete this. One with one this, and so this will store like how many times we see any particular product. Yeah, then that is a cube plus b cube. If we take a, this is a, and this is a b, so we'll get 2. If we take a, this is a, so I is a is 1 and b is 2, then a cube plus b cube with 1 plus 8 is 9. So how many times 9 has appeared in our answer? So that will store the frequency, right? And this will just store the answer. So I'll store a loop. So I'll go in this. So I'm storing like this I is learning from 0 to m. So this is 1, 8, 2, 27, and 64. And then for j is running from I to j, I to n. And then I will store what is the sum, right? 1 plus 8 is 9, and then 1 plus 27 is 28. Similarly, 8 plus 8 is 16, 8 plus 27 is 35. This is the sum that I'm getting calculated. And if this current sum is less than m, then I will increment by frequency. And if the frequency is equals to 2, that means it has appeared at least twice now. So we'll push it in our answer like this current sum. So this particular sum has appeared. And at the end, we are storing the sorting this answer, and then we're returning it. So that was pretty much it for this. The very important thing was to have the understanding of this constraint. So this particular hinted us like at worst case the list can have size of 1000, and in that case we can do a of n square solution, and that will still pass the constraint because 1000 into 1000 will 1e6, which is still less than 1e8 or 1e9. That particularly is 1 second allowed time, right? And this was one like map thing to store the frequency, such that if frequency has appeared at least twice, then only we are storing it in our answer. Yeah. So yeah, that's pretty much it for this problem. Now let's move on to the third one. All right. So what it says is, okay, you are given an integer array nums of length n, right? And index I is special if nums of I is greater than or equals to nums of I minus 1 and nums of I plus 1. That is, it means a peak element, right? So basically it says like if nums of I is this, then it should be greater than nums of I minus 1, and it should also be greater than nums of I plus 1. So this is I, then it will be greater than its relative neighbors I plus 1 and I plus 1. So that's basically a peak element. And in one operation we are allowed to choose any index I and increase nums of I by 1, right? And our goal is to maximize the number of special indices, okay, and minimize the total number of operations required to achieve that maximum, right? And we need to return an integer denoting the maximum total number of operations required, okay. So uh, let's understand with the help of this example, like 1 2 2. So in this case, if you see, right, if we want to make this element as a peak element, it needs to be greater than this and this. It is greater than this, but it is lesser than this. So if we add 1 to it, it becomes 3. So the array becomes 1 3 2, and this is a peak element. So the answer is 1. In this case, if you see, right, 2 1 3 3. So if you increase this particular element by 2, right, it becomes 2 3 1 3. So 3 is a peak element, and we can't make more than 1 because if this is peak, so we can't make it because end elements are not peak in this case. Yeah, so that's the particular thing. Like, and let's understand the constraint. It's n is 1e5 and nums of I is less than 1e9, right? So I'll copy this part because it's one of the good dry run that I have, right? The very first thing, okay, let me paste it. We'll use it later, but for now let me explain, right? So let's say we have two cases, right? It will be like, so let's see if this is the element, not like this, okay. So let's say it's like 1 and so on, right? Then if you want a peak element, right, if you want it to be a, if you want peak element, right, this can be a peak element, this can be a peak element, but this can't be a peak element, because if these two are peak element, then this can't be a peak element. So the very first thing I'll categorize it into two things for easy understanding. Let us understand if the case one, if the number is odd, if the size of the array is odd, right? In odd, how many positions can we make? Like, let's say a2, a3, a4, and a5. What is the maximum number of peak element that I can make, right? So I can make this as peak element and this as peak element. So I will have to make at least two element as peak, right? So this is the maximum number of element that can be made peak element, right? uh, so in the case if it's a odd even number, right, let's understand how many elements can we make peak element. A1, a2, a3, a4, a5, and a6, right? The maximum that I can make peak as, right, this, right, this two, or what can I do? I can make it like this and this, right? Or uh, or what I can do is I can make it as like this and this, right? But I can't make this and this, or like any other options is not feasible, right? So I see the maximum number of peak element that I can make is maximum is mm, whatever is n by 2, n minus 1 by 2. I guess it's much better. Okay, yeah. So the very simple thing that I'm going to do is, if it's an odd element, odd case, then my peak will be at this and this, because if I can make peak here, I can make peak here, right? Then the only remaining options for me to have two peaks are like this and this, because if I take this as peak, I will end up having only one peak element, and that will not be the correct answer, right? But the problem arises when we have two peak element, right? Even it's even case, in that case it can have like uh, so something like, if the array is 0 1, so let me erase it and then we'll see this part, right? If the array is like 0 1 2 3 4 and 5, then I can have peaks like something like 1 3, right, in this 1 and 3. And for here it's easy, like 1 3 5, whatever it goes, like 1 3, like not the end elements can't be made. So whatever is this 1 4, right? If it's even, then it's simple, right? If it's an odd element, if it's an even case, like one case here, the second case will be, this is case 1, the second case can be I could even go with like this, something like this is the peak element and this again being the peak element, right? So again it can be 2 and 4, right? This can be case 2, and again I can be right, okay, let let this be one element peak, and let this be the peak element, so it can be like 1 and 4, right? This is case 3, if you see, right? So I can't be like, okay, I will calculate first for the odd part and I will calculate for the even part, because here if you see, right, this case where it's contradicting, because I say this belongs to the even part, this belongs to odd part, and this belongs to even part. So this is where the main problem lies, like how do we even calculate it? Because this was very easy, right? We calculate all the odd indices like this. Second case is like we calculate even indices, right? So this and so on, right? This and this was the odd case, this is odd, this is even, but this is a mixture of even and odd. So let's understand with this example, right? This trident 615141. So it will be like 615141, 5 1 4 1, right? So my case, I need to, how many maximum peak element I can make, like 1 2 at max, 2 element I can make peak, right? Now what are those two indices, right? The first case will be like I can either make this and this as odd. So it will be like, if I do this case 1, it will be making this index and this index as odd. So this is 0 1 2 3 4 5. So it will be index 1 and index 3, right? Case 2 will be if I make this and this, right? So it will be 5, uh, it will be 2, and then it will be the next 4, right? And then I have one more, let's another case, right? If I make this as a peak element, right? I'll explain, right? If I make this as a peak element, right, then I can't make this as peak, and I can make this as peak, right? That means 1 and 4. Another case can be, let's see if you can do this. If I make, let me change the pen color and then we'll see. If I make this as peak element, then I can't make this as peak, right? And I have already taken this as peak, so this case is already covered, right? So these are the three cases that basically comes up for peak element. So what we see is, in this case the answer will be, if I want to make this as peak element, it will be maximum of this, like it needs to be at least 7 so that it's peak, right? So it will need to be incremented by 6, and again this third index is peak, so it will be at least uh, greater than equals to 5, greater than equals 5, so it will be at least 6, so it needs to be incremented by 5, so the cost is 11. In this case, if I go ahead with this case, right, I'm incrementing this, so if it needs to be peak element, it's already a peak element, so the cost is 0. If you see, right, this one, if I need to make it as a peak element, so it's already greater than its peak element, so it's greater, it's 0, right? And then I have the third case where I'm making this as a peak element, so if it needs to be peak element, greater, it needs to be this and this, so it needs to be made at least 7, so it will be costing us 6. And then I'm taking this one, right, this is already a peak element, so it will cost 0 6, and we see the best answer is this, so the answer is this. But there can be cases like where this hybrid approach wins, right? So how do it see this, right? So other than having these two cases, right, these two cases are must, like we need to have this. Other than this, we need to take into consideration this case. So how do I say, like, so I will say like, okay, so for this part, right, like if I see, right, if my index I was there here, right, not here, or say I will say it's only for odd index, right? Because in the starting it's not like I can make it like this. Let's see, I'll say explain it, something like this, right? It's not even possible that, right? So if I say 6 1 5 1 4 1, right? So it's not like I'll say, okay, till here, uh, here I will make this as the peak element, and then I will go and, so if I mark it as 0 1 2 3 4 5, right? So I say I need to at least 2 peak element, right? So I can't be like, and here if you see, right, this is odd cases, this is even cases, and these are mixture of even and odd, right? So if I've taken even, I can't say like I need to take one odd index, like, right? So if I take this even, this will be uh, already counted in this case too, right? If I take this, it won't be allowed because it's concurrent. If I take this, it won't be allowed because this will be at the end. So what I see is like, if I need to take this hybrid approach, I need to first take into odd cases and then skip some indices and take even cases. So let's see how it actually works, right? So, right, if I take this, right, if I take this one, right, even, now I need to take odd. if I take odd, right, I'm saying I won't take this one, I will take this, and after this all will be even, like all the other indexes will be even. So basically it says like at this particular index, when I had to choose this one, I have not chosen this. Instead, I have gone with the even one. So there are a gap of 2 indexes right here. So what I can do is, it will be like something like uh, previously odd index, right? If this is the index I, let's say, where I'm telling like uh, I, I should have taken odd, but I now want to take from even. Like from now, only even indexes will be considered in this part, and prior to this all the odd indices will be considered. So odd indices, right, then one gap, right, then index I itself, right, and then this part all will be even, right, even index, right. So what I can do is I can calculate a prefix sum, uh, which will say prefix sum of I, which will say what is the cost required to till this index I, or this index I, to make it odd, uh, odd places peak, right. And similarly, suffix of I, suffix sum I will say 0 to I, uh, it will say even places peak from n minus 1 to I. This will say like from this particular part coming on this up to till here, what is the cost that is needed to make. And of course we can't make the end indices like either this or this as peak, right. So this is the cases, right. And now if I'm at this index, right, I'll only consider for the odd places, because these are the places where I had the options to choose odd. I could have continued so that it falls into this case, but then I skipped, and then I told okay I will try combination. So for every index I which is odd, what I can do is, okay, so if this is I, I'll say I'll calculate prefix sum of I minus 2, right. If you see I minus 1 and I minus 2 plus what is the suffix sum of I plus 1, right, and this maximum of this two, right, and then this sum, right. And for all the I will do this for all the I which is odd, because I need to first make odd and then index, and then gap and then index and then even. So I will not do for it, and then uh, I'll take the maximum minimum across this and whatever values we get for all the odd, right. So this is particularly my approach for this one. So let's see uh, on this particular solution, right. So this is the prefix sum that we're calculating, and some edge cases to consider, right. There will be some edge cases like in this case if I minus 2 is greater than 0, then only we'll consider this greater than equals to 0, yeah. And similarly for this, if this should not fall out of bound, okay. So the very first case is like odd places, right. So I'll calculate the prefix sum, like the cost needed for every index, right. It was not even actually in that, but it's okay, fine. So I'll calculate the cost is maximum of previous and max correct next. So if I minus 1 and I plus 1 minus I nums of I, and then I will add 1 to it. So if I take this particular one, right, this one, so it I will consider this maximum of 1 and 3, which will be 3, and 3 minus this current nums, which is 1, 3 minus 1, that is 2, and I will need to make it at least greater than 3, so I need to make it 4, which is plus 1. So that is why it's like this, right. And cost should not be negative, right, because if it's already like if you take this cost, right, if you say like this is already a peak element, so 4, if you take this 3 and 4, the maximum will be 3. So 3 minus 4, which is minus 1, right, which is 3 minus 4 is minus 1, and plus 1 is 0. So it could have been like something like it could go minus. So they can be like, if it's already a peak element, then the cost will be 0. So that's particular. So this will store the prefix cost of I, and that's basically it. So any if I is greater than 1, in that case only will add the prefix cost of I minus 2. Okay, so this is basically the storing prefix cost. What is the cost required to make uh, the number at odd indexes max peak element, right? So if it is already odd case, right, if this case, right, then I know only this case is right, where this which falls at the odd indices 1, 3, 5 will be this. So if it is already odd number, then I will just return this answer at whatever answer I have taken, right? And you can see already I'm doing it I plus 2, right? So I will be only considering this for the odd indices, right? So prefix is already calculated. Prefix is already calculated. What is the cost to make the lyrics index odd? Now we'll calculate suffix, right? So I is n minus 2. I will return from this part, like from n minus 1 to I, what is the cost required? So same way this, and then suffix will also be I minus is 2. Will we're considering only for the even cases, like even indices we are calculating the suffix cost. Then result is right. The first is this one, like whatever cost this case, and then this answer second to answer case 2 is like this thing is suffix of 2, which is this case particularly, right? And the next case is for I is equals to 1. So for all the odd indices, like as I mentioned, like for this all the odd indices, which could have been the next possible, but we made it like minus 2 and plus 1. So minus 2 and plus 1. So this is minus 2 and this is plus 1, given that it falls within the range, it's not outside, and then answer will be minimum of whatever the result we have, and left plus right, and then we return the answer. So yeah, that was there are some edge cases that needs to be considered, but overall it was an easy question. Like just given this, you understand the three cases. Like if it's odd, if the size of nums is odd, then just peak will be at odd indices, right? And if if it's even, right, in that case it will have three cases. Like first case will be odd, second case will be even, and third case will be a hybrid, where previously we made peak at I odd indices, and then we left a gap um, because, and then where it was chance for odd, we skipped it, and after post that index I, we made even indices, right? So see, right, 3 so it was coming as 1, so 1 3 it should have been, but we skipped 3, and then post that we made 4 6 8 like that as even. So this is the prefix sum, and then suffix sum, even and odd, and then over this iteration. Yeah, so that's it. Yeah, but it was a good question to solve. Now let's move on to the next one. This was actually a follow-up of the previous question, right? So the same thing, right? But in this case, we are not given like we don't have the we don't have something like we need to make maximum, like given this last time, right? We had to make however the maximum was possible. So if in case if it was odd, we had to make this case, right, n minus 1 by 2, the one that I have explained below, like how many odd indices and how many odd even indices. But here if you see, right, we are given k, like we need to have at least we need to have exactly like at least k peaks, right? It was not like we need uh, maximum peaks, right? So this just the one particular change, and the second change is like instead of the array being normal, it's a circular array. So now for even this and indices, for this one the peak will be this. For this one the left element will be this, right, and right. Similarly for this, the left will be this and the right will be this 6, right? So this is two changes in this. So basically it's the same case, right? Now the only thing is like in this case the constraint of n is 5000, right, and it has decreased, right? In the last one it was 5e5 I think. Now it's 1e3 range, right? So what I basically thought is like the very first thing that we need is the cost, right? So how do I basically approach this one, right? So I'll say, right, Okay, so how do we actually approach it? So even if, let's say, I will take this something like this, right? Okay, so let's say this is the nums that is given to us, right? The very first thing that I will do is I'll say, okay, I need to make at least uh, two peaks. If you see in this example, right? So nums is 2, 1, 1, 1, and 2. I need to make at least two peaks, right? How do we even do it, right? So the very first thing that that came to my mind is like I need to find the cost, like for every indices, right? So what I'm gonna do is not, this is not cost, this is nums. The very first thing that I thought is, okay, let's calculate the cost because that will be needed at least for everything irrespective of what we calculate. So cost, right? So with this 2, what is the cost? This is the right and this is the left. So 2, maximum of 2 and 2, so it needs to be at least 3, so cost will be 1. This, it needs to be greater than 3, at least it needs to be 3. So because 2 and 1, so it needs to be greater than 2, which is 3, so it need to be increased by 2. For this one it needs to be at least 2, so it needs to be increased by 1. For this one it needs to be greater than 2, so it needs to be 3, which is it, we need to increment it by 2. For this one we see on the left it's 2, on the right it's, on the left it's 1, on the right it's 2, so it needs to be greater than equals to 2, greater than 2, so that means it needs to be made 3, it needs to be increased by 1. So right, this is the cost vector that we have formed, right, by the definition that we given in our question. Now once we have the cost vector, right, how do do, right? So I know one thing, this particular question can be broken into two cases, right? First case is if I increase, if I increment, if I make peak this index, right, I can't take this, I can't make peak at this place, right? So it can be like if I am making peak 2, if I'm making this as peak, my array will be like this, like I can't make this as peak. But if I'm not making this as peak, right, it means I'm not making this peak, so my array will be like, right, I can make all of this element as peak. Okay, and how do I actually think of like what to apply in this now? I need to make at least k equals to k peaks, right? So I thought, okay, let's imagine like if I make this as peak, right? uh, so I'll iterate over this cost. Actually I don't need this actually nums array, so let me change it, right? So we, this is the nums array, right, this currently, but for our case we'll basically use the cost array better, right? So I'll just replace it with the cost, this is cost, and similarly for this as well we have this cost, right? So what I'm going to what I was thinking is I have two cases, right, for this particular index. So what I think is if I take it, right, if I take this particular index, that means I'm making this as peak. So case one will be I'm not making this as peak, not peak. So my index will move to here and I have still have to make k, right? So if my index was there, index will increase by 1 and my k will still remain the same. But if I make this as peak, right, then the cost that I will incur is whatever is the cost at this particular index, right? Then plus whatever, if I'm making solve function, then my index, if I made this as peak, I can't make this as peak. That means if I make this as peak, I can't make this as peak. So I need to move at least to this. So index plus 2 and my key will decrease by 1. This is particularly the recursive function that I have thought, right? And the it will continue. The base case will be if k is 0, right? If k is 0, in that case what I'm going to say is return 0. we are done. If my index reaches end, I'll say okay, return that we have not been able to find at least k peak, return something like integer max or something I could store, right? And then we have these two cases, right? Case take case and then this not take case, and then I will return whatever is the minimum of both two, take and not take. This was basically what I was thinking, right? And how DP came into my mind was actually once I had this thing clearized, like my array is getting broken into two case. Like if I'm taking based on whether I'm taking the nums of zero taken and nums of zero not taken, in this is the case, right? Then my uh, array my entire questions got broken into things like okay, so my cost array will become like this. Since I have taken this, I can't take this, so my entire array will be like this, something like this, where I need to make things. And once I have this part right, I was thinking okay, could I make this as peak out of this all these places, which all elements can I make peaks, uh, like peaks, and I have to pick out of this k peaks such that they are not adjacent. And this was how like I got like DP, like recursion, the base case I've written, the recursion case I've written, and the base case was like this. And that's basically how I actually thought of this particular problem. So yeah. So once I had this recursion thing sorted, then particularly deep writing the memoization code was not a very tough one. So yeah, let's see how actually the code is written. So yeah, so firstly I calculate the cost, right, for this. And right, this is the case, right? If you are said, right, let's explain this. Let me explain this case, right? If I've said nums is 3, so n is 3, the maximum that I can make peak is 1, right? Which is, or let's say it's 5. The maximum peak that I can make is 2. That is peaks is max peak that I can make, total peaks that I can make is whatever is the n by 2, right? In case if it's even, in that case I can make this as only 1. So even case, it's like n minus 1 by 2. So I can make it like as this, right? N minus 1 by 2, right? So if they're saying like okay, k is greater than equals to n by 2, n minus 1 by 2, I know I won't be able to make it, because if they're saying like okay, k, the size of n is 4 and I need at least 2 peaks. Yeah, okay, 2 peaks, sorry, we can make it, right? Because now it's like here, and the next peak that I can put is here, right? So, and if they're saying this is n, because it's circular, right? So this one I can make, this one I can make. Okay, sorry. Okay, so at best case it's like I can make uh, n by 2, right? N by 2 peaks. But if they are saying like okay, make 3 peaks here, I'm sorry, I can't do that, because somewhere like I have to put it here or put it here. In either cases it will be adjacent, and that's not possible. So that's what I'm saying, like if it's greater than n by 2, I can't proceed with it. So if it's greater than n by 2, then I have to write minus 1. That's the particular. Else I'll write two cases, right? So if here this is index, right, and this is cost, this is just a DP thing. This is just the cost function that we have calculated here, right over here, and this is the k, remaining k that we need to pick, and this is the n. So this will basically state like what is the end. So here, like, right, I have mentioned, right? So our array is though our array n was equals to 1 2 0 1 2 3 4, right? N was equals to 5, so here we had 5 index. But if I'm taking this one, I know I can do this. So basically whenever I reached here, I know my I had to break, because I can't go for this because this is practically unreachable. So instead of me creating this array like this one, this array where this thing was removed, or in the other case where I had not taken this, so I had not taken this, so I had removed this, means instead of creating these two array particularly, I have taken one variable end which represent what is the end of this particular array. So in this case it will be n minus 2, right? So if it is, this was n minus 1, so this will be n minus 2, right? And in this case it will be n minus 1. So that particular and stores, like, instead of, so that end was basically a hack for me not having to create two separate arrays. We could have increased our space complexity. So there's basically end stores like what is the end. So it's n minus 2 for the first case where I've taken 0 index, and it's in case I'm starting with the first index, that means I've skipped this particular index, this one, right? And in that case it will be n minus 1. So if it becomes greater than equals to that, then I will return something like integer large values. Else the first case will be take, so I'll take it, and it will incur me a cost, so which I've already calculated what is the cost to make this index big, and then the solve function. So since I have taken this any function, if I have taken this part, let's say, since I have taken this one, I can't make this, so I have to move at least index, this is I, then I plus 2, so this is particular I plus 2, and then k will decrease by 1, and then end will remain the same. Else if I don't take it, my index will increase by 1. I can, if I'm not taking this, I can take this probably or not take this. So index plus 1 dp cost k will remain the same, and at the end I will return uh, what is the minimum of both two, and then before returning I will just store it into this dp variable. So yeah, that's particularly of this. So answer 1 will be this case, and then again I'm reassigning dp, and then answer 2 will be like this case, the second case, like this one, and the final answer will be minimum across both the answers that we have got. And that's pretty much it for this one, I think. Yeah, yeah, and that was an okay question given it was a 6 pointer. So yeah, that's for this video. We'll meet in the next one. Thank you.